All right, let's do derivatives of inverse trig. And oh man, it's been a while since we've talked about inverse trig. We did it at the beginning of the year. But remember, if the cosine of pi over 6 is square root of 3 over 2, then inverse cosine, this right here, which can also be written as arc cosine, of square root of 3 over 2 is pi over 6. So it's, again, it's the inverse of each other. And it could be written as one of these two things. Now, remember that the part about it is really saying, so if I say what it, I have it filled out, but when you're seeing this, it's saying what arc has a cosine of this. And if you think of the whole unit circle, then you're like, well, there's a ton. But remember, there are certain intervals that you look in. So for arc cosine, remember, you're only looking in quadrants 1 and 2. So your answer will be between 0 and pi. So that's why when it says, give me the arc whose cosine is square root 3 over 2, the only one in that principal interval is pi over 6. For arc sine and arc tangent, the principal interval is quadrants 1 and 4, but what's weird about quadrant 4 is, remember, you have to name those negatively because, again, think of it on a number line. You want a continuous interval on a number line, so you're not going to name it 11 pi over 6. You're going to name it negative pi over 6. And this guy, you're never going to get the pi over 2's because you have asymptotes there. So it looks like this. So just remembering how to get values, because if you have to write the equation of a tangent line, that's why I'm going over the values. If you have to write the equation of a tangent line or something, you have to remember those values or evaluate. So let's just remember this. It says, give me the arc in the specific interval. So I always draw the interval. Give me the arc in that interval that has a sine of square root 2 over 2. Again, unit circle, got to have that part memorized. That would be pi over 4. Give me the arc. It's arc cosine. So I'm going to draw this half moon where the cosine is negative 1/2. Well, if it's negative, I'm going this way. Negative 1/2 would be up there. What's that dude's name? 2 pi over 3. Inverse sine of negative square root 3 over 2. Again, if it's negative, I'm going to be going down. So that's down here. But how do I name him? I do not name him 5 pi over 3. I name him negative pi over 3. Inverse tangent or arc tangent of square root 3 over 3. It's positive, so it's in quadrant 1. Who has a tangent of square root 3 over 3? That's that guy, so pi over 6. Arc cosine of 0. In that interval, who has a cosine of 0? Well, that would be up top, so pi over 2. And finally, inverse tangent of negative 1. Again, I'd be in quadrant 4, so make sure you're naming that with a negative. So again, those values you will be needing to find if you have to write the equation of a tangent line and figure out a specific value. But let's get into the calculus part. Let's figure out the derivative of arc sine. Okay, well, from our first example, if arc sine of x equals y, that means that the sine of y is equal to x. Okay, I can live with that. Now let's use implicit. So the cosine of y dy dx is equal to 1. So dy dx is equal to 1 over cosine of y. But the problem is, I mean, we're needed in terms of x. So let's figure out that cosine of y business. Let's figure how I can replace this with something with x's in it. Well, of course, we love our trig identities. You know that sine squared, I'll do it with y's, sine squared plus cosine squared is equal to 1. I'm trying to figure out what the cosine of y would be. So if I solve for that, I'd have cosine squared of y is 1 minus sine squared of y. So the cosine of y would be plus or minus the square root of 1 minus sine squared of y. But with the fact that I'm in quadrant 1, and with this derivation, it's going to be the plus, so I don't have to worry about getting both plus or minus. But let's see here. Okay, you're still you're not getting there because you're trying to get it in terms of x and you still have y. Look back over here. Do you notice this statement? The sine of y is x. So right here, that's really 1 minus, if the sine of y is x, that's really 1 minus x squared. So dy dx is going to be 1 over the square root of 1 minus x squared. Simple, right? Sure. But here's the deal. As you know, is this guy always going to be just the argument x? That would make life way too simple. You're too smart for that, for the argument just to be x. So notice what we have. In the same light as we did the logs, if I looked at that as u, do you see how what this derivative really is 1 minus u squared, and the reason why that is a 1 is because what is the derivative of x? So I have u prime. And that, friends, is the derivative of arcsine of u. Now, you have options. My guess is you don't want to derive all the other trig ones. And again, we only do these main 3. So you'll just have to trust me on it, that you need to memorize. Arcsine of u is u prime, I don't like writing it like that, I'll do it like this, u prime over the square root of 1 minus u squared. Arc cosine, that should look familiar, exactly the same thing as arc sine, and slap a negative on it. And arc tangent is u prime over 1 plus u squared. Now, once you commit those to memory, and I know they're weird, again, make flashcards, whatever it takes for you to memorize something. But once you have them memorized, y'all, it's a matter of plugging them into formulas. So when I see what's the derivative of arctan of t squared, this t squared is my u. Here's what I want you to do on your homework. If you'll write it down every time, you'll probably have it memorized. What's the derivative of arctangent? I want you to write down u prime over 1 plus u squared. Just start writing it down and you'll have it. So once I plug into that formula, then I would have 1 plus u squared, and then I'm going to have u prime. If u is t squared, that would be 2t. So what is my derivative? My derivative is 2t over 1 plus t to the 4th. And there's my derivative. Let's keep going. I see arc cosine. What's the derivative of arc cosine? This is my u. Let's write down the formula. I'm going to say, okay, that one is u prime with a negative square root of 1 minus u squared. So I tend to do the denominators first. I don't know why. The square root of 1 minus 3x squared. And you can probably do this in one step. Remember to square both the number and the letter. And what goes on top is u prime. So that's a 3. But remember, I have the negative. And friends, that's it. There's my derivative. I'm done. If you know the formulas, it becomes easy. Oh, goodness. Okay. Is this product rule? Okay, look at this, because you may have a product rule one on your homework. But is this example 3 a product rule? No, because theta is my variable. Do you see 2 thetas? It would be different if that said arc sine of theta times tangent of theta. Do you see the difference between those two things? This guy, I have 2 variables. I would have to do the product rule. What we actually have is not a product rule. It's just that this u, this thing, is my u. So I'm still going to do u prime over the square root of 1 minus u squared. It's just my u is a little more complicated. So I would have the square root of 1 minus tangent squared of theta. And then on top, the derivative of tangent is secant squared of theta. And there you go. Please don't do this. I've seen it before on multiple choice. Y'all, if you have the square root of 1 minus tangent, please do not simplify that to 1 minus tangent. Okay, that denominator, you cannot take the square root of individual things with a minus or plus in the middle. So do not do that, because that's so mathematically wrong. And there you go. Now, there's one more thing I want to do in your notes, because it happens on a couple of your homework problems. Let's just practice simplifying this weird thing. If I have this, let's think about how I would simplify that, because they will never leave complex compound fractions, like a fraction within a fraction. So let's think about the steps you would do to simplify that fraction. Well, first of all, I would get a common denominator down here. And I know you can do that in your head, but I'm going to pretend, because I think on your homework it's like an x. So think about what you would do. You would change that to 4 over 4. 4 over 4, got hiccups, minus 1/4. So then that would be 1/2 over the square root of 4 minus 1 is 3/4. But remember, when you have a square root of a fraction, you can take the square root of the numerator and the square root of the denominator. So I could write that denominator that way, square root of 3 over 2. And of course, when I am dividing by a fraction, that's the same thing as multiplying by the reciprocal, and I would get 1 over the square root of 3. Remember as well that in calculus, they don't care that you rationalize. Again, if they do in the multiple choice, well, then you have to. But as far as free response, having a square root in the denominator is no big deal. So if it's free response, just leave it. But yes, if it's multiple choice, you do have to, know that those are the same thing, but you don't have to actually work it out and do that every time. So that's what you'll be doing on your homework tonight. Practice those, get those formulas memorized, and sometimes you can use trig identities. If you have trig, you always have to think back to trig identities and make sure that you do those. And that's it. So peace out.